If you're anything like me, you can feel a bit schizophrenic at times while working with React. On the one hand, it can feel as easy as snapping together Lego blocks, but on the other, you run into terms like idempotence and purity, render phase and commit phase, concurrency, and it can be a little confusing to know what all these terms mean. So in this video, I want to go over each of these terms, so hopefully you have a better understanding of what they mean when you come across them in your React journey. So the first one is render phase. So like Vue or Angular, React is a library for rendering user interfaces. But if you ever come across the term render phase, that means something more specific. See, React breaks up the work it has to do to render your app into two phases. And the first one is called the render phase. And this is where React executes all of your components and gets a JSX tree as a result. Now, if it's the first time React is rendering your app, it will just return the entire JSX tree. But if it's an update, like most renders are, it's actually going to get the new JSX tree and compare it with the old one and compute a diff. And this process is called reconciliation. It's a lot like when Git looks at two snapshots of a repository and computes a Git diff. So somewhat ironically, the render phase is all about computing this diff rather than actually rendering pixels to the screen. That's for the second stage of rendering, which is called the commit phase. So once React actually has this JSX diff, it can begin the process of updating the DOM. So it does this by seeing we need to add an h1 tag, looking at the current DOM and seeing there isn't one, and then calling document.createElement so that those two trees match. So the commit phase is all about actually applying visual updates to your current website. And again, thanks to the diff, React can be really intelligent with how it goes about actually updating the DOM, while we as developers still get to write our code declaratively without having to keep track of what things stay the same and what things change over time. So how does React actually know which parts of our app change over time? Well, this is where state comes in. State is runtime data that React relies upon in order to render your app. And this data changes over time and typically affects the visual output of our app. Now, it's worth noting that there's other data that changes over time that is part of our application, but not part of React state. And this would be things like our scroll position or our mouse position, which element has focus, or what text is highlighted in the browser. The browser keeps track of this data, but because it doesn't live inside of React or trigger re-renders of our application, this is not React state. But for our state, React lets us define it, and React also gives us a function that we can call to update that React state, and the updater is the primary way that we trigger re-renders of our application. So state is precisely the thing that makes React reactive. And as a corollary to state, we have side effects. So if the point of our render function is all about returning JSX that React can use to calculate a diff and then actually apply to our web page in the commit phase, any other code in our components that's not directly related to creating or manipulating JSX can be considered a side effect. So fetching data from an API or updating the document's title or even console logging are all examples of side effects. Now, I will say there is some nuance here about what exactly a side effect is inside of React, and some developers even might disagree about this. But as a general rule of thumb, when you're talking about a React application, you can pretty much assume that any code that is not creating or manipulating JSX is a side effect. Okay, now the next one is pretty interesting, and this one is purity. If you've been writing React for some time, you've probably heard that render functions should be pure. But what does that mean? Well, one way to define a pure function is a function that has no side effects and whose output depends solely on its input. Now, the concepts of side effects and purity apply to programming in general, but for the sake of this video, you can think again of side effects as anything we talked about in the previous section. So setting up a subscription, logging, manually manipulating the DOM, or fetching data from an API. All of these are side effects, and if they were in your render function, they would cause it to be impure. And this is why even writing new date in your render function causes your render function to be impure. Because if we were to run that over and over again with the same set of state and props, well, that new date is an impurity and it would cause us to return a different result each time we render it. So remember, purity, a pure function, means that your function has to return the same output for the same set of inputs. So you might be thinking, well, I need to do side effects in my application. I have to fetch data or write data or even show the date. How do I do it? This is exactly what useEffect is for. When we use useEffect in our components, we're basically removing the impurities from our render function. We're kind of marking them, the side effects, as separate from our JSX calculation. And that gives React a chance to kind of queue up all these side effects and execute them on its own terms. But render itself should be pure. That is kind of an assumption that React makes in order for everything to behave correctly and for our React apps to take advantage of some new features we're about to talk about. But first, we have one more concept. It's called idempotence. Now, this is another term that describes particular kinds of functions as they relate to those functions' side effects. So an idempotent function is a function whose side effects have the same effect on the overall system state, no matter how many times those functions are called. And I think the best way to explain this is with an example. So if you've ever worked with database seeds before, you might be familiar with writing a seed function that gets called when you deploy your application. So say you're working on an app that has a database table of all the countries, so you can show them in a dropdown for your users. And when you first deploy your app, you run your seeds file and it creates United States of America as a country. So now you make some changes to your app, you redeploy it, and you want to run that seeds file again. You want to run it every time you deploy so that your app works in any environment. But you wouldn't want to create United States of America again. You wouldn't want to have it twice in your countries table in your database. So you make your function idempotent. You say, first, if I don't have United States of America in the table, let's go ahead and insert that row. Otherwise, we won't worry about it. And this is idempotence. Your seed function is now idempotent, which means it can be run over and over again. It doesn't matter if you run it once or 20 times. You're still going to end up with the same final result of countries in your database table. And in the context of React, we usually talk about wanting to make sure our side effects are idempotent. And this is exactly why useEffect gives us a cleanup function. Let's say we put a side effect inside of useEffect and it sets up a subscription. We know we're supposed to clean up that subscription when we return. So when that page or that component is unmounted, it should clean itself up. And this way, React can mount and unmount and remount that component. And we're not going to end up with 20 subscriptions in our application. So if we want to have well-behaved React components and React apps, we want to follow this rule of keeping our components idempotent. And that means basically making sure our side effects can be run over and over again without screwing things up in the wider system state, without creating 20 subscriptions. Basically, if we clean up after ourselves, then those things can be run over and over again, just like that seeds file from our database example. Okay, so the next one I want to mention is heuristics. And of course, this is just a general word that kind of means guidelines or principles. But you'll hear this come up sometimes when the React team talks about React, and especially around some of the features coming to React 18. And heuristics are basically guidelines or principles that we need to follow if we want to be successful with React, if we want to use it as the designers of the APIs intended us to use it. So React can't deterministically find side effects in our components, which is why it's important for us to learn what a side effect is so we can put it into useEffect and learn how to make it idempotent so that it can be rendered over and over again. And this basically comes back to this heuristic of render being pure, render being idempotent as something we need to follow. Now, it can be a little weird because sometimes you can bend these rules or not follow the heuristics, have some impurities in your render function, and maybe your app is okay. Maybe you don't see any bugs in it or anything wrong with it. But it is an assumption that the team makes and has been part of kind of the documentation and the educational materials around React for a long time. That is, again, going to give the React team and the library more power in the future. If they can assume everyone's render functions are pure, they can do all sorts of cool stuff with our applications that we haven't even thought about yet. And that's what we're going to talk about next. So you might be wondering, what does render and commit and idempotence and purity kind of all have in common? Why are these things related? Why are we talking about them? Well, the answer is React 18. And this leads us to our final term, which is concurrency. So if you've heard about suspense or transitions or interruptible rendering or scheduling, you've been hearing about Concurrent React, which is a set of features that's coming to React 18. So what does it mean? What does Concurrent React mean? Well, in React 17, rendering is synchronous. So React only has synchronous rendering. And what synchronous rendering means is the moment a render is kicked off, either from an initial render or an update, and React starts running that render phase, nothing can interrupt it between the time it starts render and it gets to actually committing those updates to the browser. There's nothing that can happen that can stop all of that work. It just happens in a straight line until it's done. But in Concurrent React, in React 18, that's not the case. So React can actually see that there's an update. It can start preparing that update in the render phase, calculating that new JSX tree, that diff, and then something else can come along before it decides to actually commit those updates to the DOM. So rendering can be interrupted. So that's what interruptible rendering means. And the reason it's doing this is because it can be much more intelligent about how it breaks up all of the work that it needs to do. Let's say a user's typing in an input field, and as soon as they type, we need to re-render some large graph right here. And so that render and commit phase kicks off. But sometimes it takes a lot of work. The render phase can take a lot of work to calculate this new tree, and it can even lock up the browser sometimes. So if React is able to keep these two parts separate, it can start doing this work, but every so often yield control back to these higher priority updates, like a user typing in an input field, which should always feel responsive. And then maybe the user types, they get a new query, and then React decides this last tree that we were preparing is no longer needed. Let's just toss it out and start again without ever going through that commit phase. So this is the scheduling part, and it's what makes React 18 apps potentially much more responsive and resilient under these kind of heavy load, heavy render situations. So if you think about that, it makes sense why the heuristic of render being pure is so important. Because if React can assume that all of our components are pure and that if I run them, it's just a pure calculation. I'm just taking an input, calculating a JSX tree, and that's it. I have no side effects. I don't mutate any global state or change the world in any way. If that heuristic is followed, if that assumption is correct, React can now render different versions of our app at the same time without having to commit them to the actual browser. So let's say you want to prepare another screen. You have like a modal wizard and you want to be able to swipe in a new screen. React could actually prepare that in the background so that it's ready. So when the user clicks next, you can just animate it in right away. You don't have to wait until they click it to start manipulating the DOM. Or you could prepare it something that was off screen and then decide, hey, we don't need this. They hit cancel and it just goes away. So React is basically going to be able to render different copies, an arbitrary number of copies of our app in memory. And again, it has to be able to assume that our components are pure for this whole thing to work. There's already some awesome features like suspense and transitions in React 18. You can read about it in a release blog post. You can start using them today, and they rely on this feature. And then there's some even more really cool stuff coming. The React account was tweeting about an off-screen component, which is kind of similar to what I was describing, where you could unmount or hide part of your app to save memory or clean up subscriptions, even if the user tabs away from your site. And then when you come back, React basically has that in memory and it can just recommit it to the screen right away. So all this cool stuff that's coming to Concurrent React relies on your render being pure, and that's why all these concepts are so important. Now, if you have jumped into React 18, you might have heard of this thing called strict mode. And strict mode has changed a little bit from React 17 to React 18, but basically the whole point is related to what we've been talking about, which is trying to help you make sure that you're writing pure components. So for example, one thing strict mode will do is when you first render your component, it's going to mount everything, which is going to create your components, use effects, and use layout effects. Then it's going to simulate immediately unmounting them. And so it's going to run the cleanup functions for all those effects. And then it's going to simulate remounting them with whatever the state was at the time. And it's going to create those effects all over again. So you can see if you have components that are just creating, one subscription every time they re-render, they're not cleaning up after themselves, this is going to cause problems. But the point is to surface bugs related to this whole concurrent React pattern so that you can remove those impurities, make sure you make your effects idempotent, and that way your components and your apps are going to be ready to take advantage of all these awesome features coming to React 18. So that's what I want to talk to you about today. When I was learning React and I came across terms like purity and idempotence, I didn't take time to learn what they meant in a really deep way at the beginning. We're all busy. We're trying to get a to-do list item rendered on the screen. And, we have to decide when it's worth diving deeper into specific areas that we don't know a lot about or are not comfortable with. But these ones kept coming up, especially as I was watching the React team talk about React 18 and concurrent mode. And I do feel like even though in some sense they're an implementation detail and the technical details are hidden behind React, it is important for us as React developers to understand these concepts because they are how the library is intended to be used, and they will help us write well-behaved components in our React apps that are going to behave great and, again, take advantage of all these new features that we weren't even thinking about. We weren't thinking about an off-screen component that could prepare a new version of our app in the background before, but as long as we adhere to these guidelines and heuristics, we will be able to take advantage of that in the future. So I hope that helped. Check the link below in the description. I have some links to some of the materials I read for this video. One is the rules of React, which is from a React core team member. And it reads more like a specification, but you should be able to read it and get a sense of kind of what it's talking about. It's a lot of the stuff we talk about in this video. And there's also some nice technical docs from the React advanced guides, the official documentation that goes into reconciliation and some more stuff if you want to dive deeper. But I hope that helped. If you made it this far, thanks a lot for watching, and I will see you in the next one. Bye-bye.